call. All right, so I think you guys probably have some general feeling about BIM. Can anybody tell me, based on experience learning Revit, what is building information modeling? Anybody?
It's like an integrated model where we can like model the structure and put like important information for every structural piece in this project, such as, I don't know, a concrete member or yeah, basically like concrete members or steel members. You can put pictures and that type of stuff.
Yeah, so great. You mentioned 3 keywords: integration, model, which is the geometry, but as well as the information, right? What else? Who else has an opinion? Okay, so let me ask you another question. Out of the 3 words in this term, building information modeling, which one is the keyword? Or, you know, if we want to rank it, which one has the highest priority? Information, exactly, correct. I think you guys have a very good understanding. So this is not only about the modeling, this is not only about the building. So that's why today we also have civil information modeling or city information modeling. So actually this is more about information. So we are using modeling or model as a platform, as a storage for information, because I will show you in a moment, information is the key to the construction industry, and it's also the source of a lot of ineffectiveness and inefficiency that we observe in the construction industry for a long time. So let's talk about the building information modeling. Actually, building information modeling has 3 main features. And number 1 is this is object-based. I think I shared this story with you, like when I was learning AutoCAD, it was extremely difficult to plot like a toilet cabinet, right? You have to consider all the curves of lines, because in the eyes of a computer, they still see them as a bunch of lines, as a bundle of lines. But building information modeling treats is different. So if you're talking about a toilet cabinet, it is a toilet cabinet. If you're talking about a chair, it is a chair. So what they are doing is actually you retrieve that entire object from the library, and you can change the parameters, of course, but that object is a mass, it's a component, it's a something with with the touchable information and also with a concrete mass related to it. So that's object based. That's the number 1 feature of building information modeling. And like I said earlier, it is actually very similar to Minecraft game. Let me play some quick video about this object-based feature. This is actually for those who are not familiar with Minecraft, this is a video of Minecraft, just to wake you guys up. In fact, people are using Minecraft to create a city. It's kind of like the designers creating buildings. That's object, okay. Okay, let me stop here. Just to give a sense at how Minecraft looks like if you're not familiar with it. Uh, in fact, my son is a big fan of Minecraft. Whenever he has time, he just go there and build his city. You would be amazed by the things he created. He's 7 year old, and in fact, the out of the different age groups, age from 8 to 18, I think, actually is the #1 player group for Minecraft. And they probably spend, I saw some statistics, they spend on average 4 hours a day playing Minecraft and creating things. And you can check this Minecraft Wikipedia. I think now they created a world, a virtual world in Minecraft that is 5 times bigger than the actual world Earth. So just imagine how much energy, how much effort they actually spend in creating things, and that's actually some kind of like a game version of building information modeling. So this is actually some example I found online that the cities they created. Like they also created the entire skyscraper, and they also created the entire, downtown. This is Hong Kong, and also New York City. So you can find a lot of amazing projects. And the reason it's kind of easier for them to do it is because this is totally object-based programming, object-based design, all right? And the second feature of a building information modeling is this is information rich. That's why we see the keyword is not building, it's not modeling, but it's information. It's the information integrated and embedded in the 3D models. So we're talking about information for pretty much all phases of a project, from the architecture design to the structural design to the bidding process. Here, architectural design, this is more about geometry, texture, volume. Structural design, this is more about like the load, force. Of course, you can also store, like for example, the static load and dynamic load information in your building information model. And also, we are talking about information for supporting bidding, like the cost information, conceptual design, erection drawings, detailing. So detailing is something for the shops. Like if we want to create some special shape beam, and usually you just create that virtual model and send it to computer. The computer can basically punch the holes in the right location, things like that. So we're talking about a really high level of development, high level for details. So that building information modeling can also support and store that information needed for the shops. And we're also talking about like procurement and purchasing. Like it's very easy from your BIM model to generate a schedule or bill of materials. So you can send it to the procurement department to generate a PO, purchase order, very easily. Fabrication, scheduling, we can store the time information into the components, and it's very easy for us to visualize and simulate how the structure is built up. So the second feature is information rich, and information actually differentiates building information modeling from the previous way of digital design. We covered a brief history of BIM, and if you think about that, we moved from this paper-based drawings to 2D CAD to 3D CAD, and finally to BIM. The difference is not only about the third dimension, right? Otherwise, BIM would be the same as 3D CAD. So the biggest difference moving from drawings 2D, 3D, and I probably should have a line here and jump from the line across the line to BIM is information. None of the 2D, 3D drawings would give you the chance or opportunity to store useful information inside the model. They only store one type of information, which is the geometry, the size, right? X, Y, Z. But right after BIM, the invention of BIM, we start to be able to store more and more information into it. And this is actually a visualization of how BIM is different from the previous solutions, digital solutions. Just imagine here the lighter color as the geometry information that in a design model, and the darker color shows the other information such as the types, attributes, and relations. That shows, for example, the type of the material used, the type of the particular building components, The attributes can be like the weight, the insulation rate, the PSI number of concrete. The relations can be the desk must be on top of the floor, the ceiling must be below the floor, you know, that kind of relationship. So 2D, 3D, they include only minimum such additional information. But moving from 3D, you know, when we add these assemblies, we start to have them more information. But because you have this object-based design, that's the number one feature, right? It is, from the computer science perspective, possible to add and store additional information, because, you know, if you guys are familiar with object-based programming, it means a package, and this package provide a place to store all the information. So the biggest difference is actually here, not the geometry. And talking about the information, we know different parties have different needs for information. So for example, if you are the owner and you now needs to design a door, so for the designers, you know, designers might think about, you know, what is the color of the door, what is the material of the door, and how do we meet the code requirements. The contractors might think about the number of doors, the count of the doors, how much the door cost, and how the door would arrive, who is sending doors. For facility management, you know, that would be how frequently I should oil the door, the closers, and where do I order the replacement. So just think about the diversity of information needed for just a single object inside a design. And because of that, BIM develops a very complex hierarchical structure to store all the information. We covered that last week. That's what the parameters, right? So we do have different parameters, family parameter, system parameter, project parameters, but we also provide the flexibility for you to add your own parameters, because we never know what new information would be needed for a new project, what parties, their requirements, right? So we actually allow you to create your own parameters. That's actually the information tab that wouldn't be needed in the project. And this is a very important slide. Like I mentioned, BIM, the fundamental difference between BIM and 2D CAD, 3D CAD is additional information stored in the objects. And that's called ND BIM theory or definition. So for the 3D BIM, let's say that's the beginning part of BIM. So we basically store the geometry information, the relationship information. And the 4D BIM means we add time information to that. So for example, if you open the property window of a concrete pad, so that view basically shows you how long this concrete pad will need to pour the concrete pad. So that's time information. And we call this kind of BIM model 4D BIM. And this kind of application called a 4D BIM application. And the 5D BIM is adding cost information in addition to 4D. So let's say if you open an object, and you will be able to see the unit price of that, the labor cost of that, the material cost of that, and also the quantity of that. So that's 5D BIM application. 6D means on top of 5D, we also add sustainability information, such as the energy consumption. And if this is a window or door, it probably will be related to their insulation rate, Energy Star score. You know, those things that directly contribute to the sustainability evaluation or sustainability performance of the building. If your BIM model has such information, we call it 6D BIM. And finally, we have 7D BIM, which is more related to facility management. You know, facility management is very different than design or engineering. The things that the facility manager cares are fundamentally different than what the engineer cares about, right? So it can be when I should perform the maintenance, the frequency we should perform the maintenance, the cost to replace something, and also the, let's say, the supplier information, the supplier number, those kind of information. So talking about applications, for 3D BIM, the biggest application in the BIM world is clash detection. I think we covered that, right? So clash detection means to find out the spatial conflicts of in your design, like if a light fixture is blocking the way of sprinkler, then that is a conflict. If a pipeline going through a wall, then that is a potential conflicts, right? So 3D BIM often be used to run clash detection. 4D BIM is often be used to run animation simulation. So we actually can combine this bar chart from this P6 software or Microsoft project software, or just a simple Excel spreadsheet. We can integrate that into this 4D platform, and so we can see how the building is built up. That's called 4D simulation or scheduling simulation in BIM. 5D can be used to run this cost estimating. So I showed you guys a very quick demo, and we have this BIM model. We have the unit price built in. So just click one button. I have a spreadsheet with all the quantity takeoff, as well as the total price for the project. That's 5D. 6D application can be running the lead evaluation. You guys know lead, right? You guys know the meaning of lead? Nobody? You guys are quiet. So the lead is, yeah, go ahead.
It's like environmental efficiency for a building. Like it's like a rate that it's really friendly with the environment in its construction and like management and stuff.
Yes, so lead is the leadership in environment and energy development, something I forgot the D. So it's actually a widely accepted standard to evaluate the sustainability performance of your design. It's not only the building, right? So that involves like the material you are using. Did you use a lot of recycled materials? And how many parking space you have for electric cars? How close your building is away from the bus stop, so people can reduce the use of their own bus cars. The air circulation you are using, how would you reduce the use of artificial lights but use more natural lights? Those kind of stuff, they have a very holistic evaluation system to give you a score, and based on score you receive different LEED certificate, like a LEED premium, LEED gold, LEED silver, right? So we do have a LEED gold building or silver building on UF campus, and that's the Rinker School building. I think that's a gold building. So that means the carbon dioxide footprint that you are generating is actually very small. That also means the life cycle impacts of your building to the entire environment is actually very small. I don't know if you guys know about that. About actually more than 80% energy is actually being consumed by buildings. There's a data, I forgot the exact number. But anyway, the point is we human beings actually waste a lot of energy because of buildings. So we need to think about how we can use the air conditioning, how we use the light, how we use the space, everything smartly, and also how we build things smartly, like how do we reduce the waste during the construction process, during the logistics chain, the supply chain, and to reduce the impact to the environment. That's called sustainability. And there are some add-ins and analytical components in BIM, in Revit, for example, help you analyze that and give you a score. So for example, one thing that we could show, maybe not this week, but later, is we can run something called a building facade analysis. So basically, given your current GPS location and all the SAM pass, we design a certain building and a certain orientation. This model can predict the energy consumption of your building. And so as a designer, you can change the facade design, or you can rotate your building in different way. And you would be amazed at how much energy you can save just by rotating your building. That's actually sustainability. Very smart using BIM. Imagine using AutoCAD to do that kind of study. Impossible. 7D, that's facility management. And there's a standard called COBE. I think we talked about it in the history. Can anybody tell me what a COBE is about? Anybody? So COBie is actually the military standard for facility management, right? So it's pretty much just a Excel spreadsheet and showing what facilities and their status, right? So COBie, let me just show you how it looks like. It's basically look like this. So you see this is the BIM model, but this is the spreadsheet. That spreadsheet shows important information like the name, the categories of that, description of that, manufacturer of that, and of course you see also, you know, like something about floor, about a space, about type, about component, about system, about assembly. And the COBie is actually, imagine it's a standard spreadsheet that you should follow the same exact column names to store the information for facility management. That's COBie. And there are also add-ins in Revit that can export this COBie form directly. And since this is standard, so you can easily exchange this form with your facility management department or suppliers, and they can use their software to read it and generate reports. So that's actually the 7D application. All right. The third feature of BIM is BIM is actually more than just an individual solution or a software solution. It's actually becoming a business solution for the entire industry. A big problem in our industry is so-called, let me just find it out if I can show that quickly, is something so-called interoperability issue. So the interoperability issue means, I don't know if you guys have any intern experience or work experience, and if you are, just name the programs your company use, that's a lot. So let's say my company use 5 different programs, your company are using 5 different programs. So the interoperability issue means I generate a report or some kind of a file. It cannot be read by any of your programs. So I have to translate my file or convert the format of my file. That additional cost is about, let me see the total number. Total number is here. It's about $15 billion. So the number should be million. So it's about $15 billion per year. So we're actually wasting that much because of the interoperability issue. This is the NIST data. So the industry has been trying so hard to find a common standard. So imagine in a day, all programs, it doesn't matter if it is a program for estimating, for scheduling, for safety, for labor force management, or for design, okay, like your structure design or architecture design, they use the same file extension, dot something. And so I want to do estimating. I have a very different purpose than a structural engineer, but I can still open the same document, open the same file, but I just focus on different aspects of that model. That is the industry standard that we have dreamed a long time. In that way, we're going to eliminate the use of different programs, right? So do we have it? Yes or no? We cannot say we have it now, but the industry started to notice that BIM provides a historical opportunity to have this common industry standard. And this is something called IFC, Industry Foundation Classes. So it was actually originally developed in 1995 by Autodesk and the other 12 other US companies. So what they are doing is trying to develop the common language to describe a building and also the project. What I mean? So if I'm porting this one, so can anybody tell me what's this? Just use a word to describe it. This one. Anybody?
What's that, sorry?
Yeah, so what's this? Just name this, name the thing that I'm pointing to. I'm gonna call you guys, okay? If you don't volunteer. Alvaro, since you said something, can you name the thing I'm pointing to? Anyway, it is that's a desk, right? Yes. Can I call it a table? Right? Can I call it office desk? So for the same thing, we can give it different names, correct? So think about that, you know, for a software ABC, the software engineer or the programmer, when that guy programs this object, maybe he give it a name like a table, T-A-B-L-E. But then another program just happened to give it a different name, desk, D-E-S-K. We know, human beings know, oh, table, desk, it mean pretty much the same thing. But that means different 0 and 1s for computers. They don't know that they refer to the same thing. That is a big problem. You guys understand what I'm saying here? So that is the original motivation of having this industry foundation class. The original thought is very simple. Let's list all possible things inside the building and give them the same name, okay? Let's use the same name for everything. And the next thing is, let's define their relationship so the programs wouldn't do stupid things. For example, the light fixture must be attached to a ceiling. So the relationship between a ceiling and the light fixture is light fixture to ceiling. So if I have a floor, or if I have like a ground, a concrete pad, and I try to attach a light fixture to that, you would receive warning inside the program. So the computer can become smarter, knows that relationship. And we don't have anti-gravity. So if I have a table, it must be sitting on the ground, okay? So table on ground. So the on actually defines relationship. So industry foundation class is nothing but just a very clear, very strict description of everything and the relationship among them inside the building, okay? That is extremely important for computer programs to understand that. And if we have that, we have the common understanding, and that becomes possible to use the same file extension. And that extension is called IFC. So today, if you open whatever program you're using, let's say this is Revit. Of course, if you save it, that's a RVT file, but it always give you this option. Why is thinking? Okay, always give you this option of saving as an IFC file. So once you save it as an IFC file, you can send this IFC file to other. It doesn't matter what they are using. They could be using, Construct Sim. They could be using, should I forgot the name? Bentley. Okay, they could be using different programs, but they can always read this IFC file because the code embedded in this IFC file is actually using the same names and also the same relationship. So let me show you how IFC looks like. This is how IFC, the metadata looks like. What do you see as 3D objects? The computer sees them as lines of scripts, lines of codes. The lines of code just describe the name, the property, the attributes, the location X, Y, Z, the dimension, the length, the area size. If we define them in the same way, of course, we can exchange them between different programs. This is actually another view of IFC file. Make sense? So it's possible for you guys to use just a text TXT file to open IFC file, and this is what you see. But when you send this one to Revit, Revit will interpret that as 3D model and show you the 3D model. No more than that. That's it. Okay, so the third feature of BIM is its industry standard. So that's actually the 3 features of BIM. Number 1, object-based. And because it's object-based, it's possible for us to save a lot of information inside it. And that's actually the information rich. And because we are saving so much information in it, it's possible for us to define them in the same way. And so it's possible for us to have the first ever industry standard for design, for model. And that's the third feature of BIM, industry standard. So what is a BIM? The definition, actually, we have this very specific, clear definition. Building information modeling is an intelligent 3D model-based process that equips architecture, engineering, and the construction professionals with the insight and tools to more efficiently plan, design, construct, and manage buildings and infrastructure. That is definition given by Autodesk. So what you see the keywords here is first, building information modeling is not a model, it's a process. It's actually a business management process and equips all disciplines, not just engineering or architecture, but also construction. And also it covers all phases of project, from the plan to the design, to the construction, to the facility management of buildings and infrastructure, okay? And similarly, this AED lab gave us a similar definition. Building information modeling is an integrated digital process. Once again, it's a process providing coordinated, reliable information about a project throughout all phases, from design through construction and into operation. All right, guys. The biggest thing about a process is involving people. So the bottleneck of a BIM is not technology anymore. It's more about how we re-engineer your current workflow, how we engage people in this process. Because if BIM is used 100%, it means from the first place of design things to applying things to design things to bidding to construction to facility management, we have to totally give up our traditional way of doing things, okay? And we have to use this centralized place to do things. So this is a quick promotion video by Autodesk talking about BIM. I think this is impressive. For the simulation, different projects, class detection, site management, fabrication, shop drawing, traffic simulation, underground utility. Scanning, modeling, as-built modeling. Construction coordination, 3D printing, this is more for fabrication, automated construction, cloud applications. Once again, photogrammetry and scanning. This is a great video because it shows different aspects of BIM. I want to open your eye, to see BIM is just more than Revit. BIM is more than the design of something, but design is the foundation of that, right? So once you have the digital model, there's a thing called a digital twin. So we are building something virtually, so we can play with it. We can test the energy consumption of that. We can run this occupant behavior simulation, traffic simulation, energy use simulation. We can test and simulate the structural performance given different loads and different winds, hurricane. We can simulate how that affects traffic. We can simulate when you try to build it, how different subcontractors are fighting each other, spatial-wise, space-wise, and time-wise. I don't know. We can also, run this facility management thing to simulate how frequent I should maintain it, and also have seen people using it to plan out how many surveillance cameras should be placed inside the building to have the maximum coverage. It is actually the replica, the digital replica of the real world for a lot of amazing things. So that's actually building information modeling. It is a collaborative information sharing process, a risk mitigation tool, not software, not just a 3D model. All right. So this is a quick talk about the BIM definition, the features. Any question, any comments from you guys? You guys have been very quiet today. Anybody? If no, I'm going to call your name and ask questions, okay? All right. The big question, it's not a question anymore, I have to say, but I started teaching BIM about 5 years ago. At that time, still many people ask me, you know, we have been using this paper and pencil for a long time. We have a lot of engineers trained how to use AutoCAD and the printed drawings to coordinate everything. Why do we need BIM? Okay, I want to show this one quickly. I will stop here for you to read it. So this is what the customer really needed, what the project team understood it, how the architect designed it. This is very impressive design. How it was actually constructed, what was the customer received, and how the customer was billed. So this figure actually shows the misunderstanding in construction projects. You know, the parties, the owner, the designers, the architects, the general contractors, subcontractors, nobody understand the true intention, because I cannot go into your brain and see what you are seeing in your brain. It's more verbal communication or, you know, drawing-based communications. So there's often miscommunication. That's actually the biggest source of inefficiencies in civil engineering. The AEC industry, the AEC project, is actually a multiplayer game. So question now, what is AEC?
Architecture, engineering, and construction.
Exactly. So that is more than just engineering. This is architecture, engineering, and construction. It's a multiplayer game. So it involves people, let's say the owners, the users of the building. Sometimes the owners and the users are not different parties. The designers and engineers, the general contractors. Usually the general contractors also include the construction manager and responsible for scheduling and estimating. We have sometimes we have the fabric shop that is doing the, you know, like the steel fabrications. We also have, you know, the subcontractors, also some outside organizations such as, you know, you have to deal with the governments, you have to deal with the environmental, you have different building codes to follow. So a single project actually means a lot of people, organizations, and parties involved, right? And the core of a project actually involves, you know, owners, designers, and contractors. You probably are very familiar with this, but actually we also have subcontractors. You know, usually for a big project, we are talking not just about 3 or 4 subcontractors. We are talking about maybe 12 or 20 subcontractors. And most general contractors in the United States don't do a lot of work themselves. So I have to say, for most of the commercial projects, the general contractors outsource about 90% of their work to subcontractors. That's probably why their profit margin is very low, because they are sharing profits with the subcontractors as well. So a lot of the general contractors, they only do concrete, and the subcontract their, let's say, the frames, the subcontract the windows, the subcontract doors, the subcontract especially drywalls, lighting, MEP to different subcontractors. And we have suppliers, right? So if you want to buy things from suppliers, you have to consider their impacts in your project, such as their lead time for delivery. I was working for Zachary. I think I said that. And Zachary is building a lot of power plants. So there are only a couple countries in the world that can produce the turbines and generators. And a very important component for power plants is HRSG, HRSG, heat regeneration steam generator. So for example, Germany can and Japan can produce the turbines, and South Korea is probably the only one country can produce HRSG. So then the supplier actually play a very important role in the project, because just think about that. It takes them about a week to just tie up the HRSG and take them about a month to ship the HRSG from South Korea to Houston, and take them another week to untie the components and then ship everything to the site. So that they actually play a very important role. And that's the first layer on top of the primary core of a project player. But we also have inspectors. We have utility companies. So like before a project, you need to call the utility companies to make sure the utility lines are okay. And you also need a temporary power support and temporary water support. That's all utility companies. Of course, you also need to deal with the insurance company, the bond company, and also labor unions. Especially in North, the labor unions play a big role. A lot of construction general contractors are using union laborers in the North. And of course, you have to deal with the government, the regulations, the building codes, the financial institutions to get the loan, and also trade associations such as AGC, ABC, and also educational institutions. So think about how many parties are involved in a project and how difficult it is to have this common understanding. But it's more than that, guys. It's also about different interests. So the construction or the AEC industry is highly fragmented. What do I mean? Let's imagine that, for design and engineering and for, this is construction, basically we have different contracts for different parties. Imagine you are a big company and you want to build a new office building. So you definitely sign a contract with some design company or design studio. And once they offer you this design, deliver this design, their job is done. They just walk away. And what you have is the drawings, the design of your future office building, and they send it to the engineers, and you will send some kind of a structural design or mechanical design contract with the engineering company. And when that is done, once again, their job is done, they will walk away, and they will send everything to what? To the general contractor. And the general contractor will build everything, and their job is done. Finally, they deliver the project, and they also deliver the menu, the specifications and the drawing to the facility management or you. So you basically take care of the building in the remainder life of the building. So think about this process. It's not integrated. It's highly fragmented. And talking about, but on the other hand, talking about information, everybody relies on everything. So like, for example, if you are the general contractor and you want to have the, you want to come up with the cost of a particular, let's say, area of concrete. So you do need information about the design, right? So you need information from the engineering company. And also you probably need information about the labor productivity. So you need information from the HR, like what is the labor cost and how fast they can finish the job, right? And they also need the information from the material supplier, right? So you know what's the unit price for concrete per cubic yard. So on the one hand, the information needs is significant. Everybody needs information from everybody else. But on the other hand, there's no obligation for them to work together or sit together. So it's organized in a way that everybody tries to finish their portion of the job and then walk away. So that kind of a mismatch creates a unique phenomenon in the AEC industry, which we call fragmented industry. That is the source of pretty much all problems we are seeing, the low profitability, the low productivity in the construction industry. I shared a number with you guys. I want to share that again. The number of waste of a typical building project is estimated at over 50%. What do I mean? You build a building that costs you $10 million, but you actually spend about $5 million in the actual building, buying the materials, buying the labor hours, building things up. The other $5 million can be considered as waste. The waste is due to miscommunication. So of course we have some waste that cannot be avoided, but about 30% of that, let's say $3 million, can be saved with improved communication. If we can force everybody to sit together and in the same room, under the same roof, and they like each other, very likely we can save about 30%, $3 million from that project. 56% of project cost is put at risk by ineffective communications, very similar. And 1/3 of project failures. What is project failures? Like I build this foundation and found it doesn't work, or it didn't serve the function as planned, so I have to redo the work, things like that. 1/3 of that can be contributed to the ineffective communications. And the interoperability issue I just mentioned. Okay, so that is actually the biggest problem or the source of problem in construction in the AEC industry. Now, you probably would ask, okay, if we know that's the problem, why didn't we try to solve the problem from, let's say, contract design or from some organizational design? I want to give you a quick example. The auto manufacturing industry, the car manufacturers, they had a similar problem before. About 150 years ago, it's almost 100 years ago, 150 years ago, you know, think about that. If you want to build a car, you have to buy the wheels from a company, you have to buy the engines from another company, you have to buy the glass in the windshield from another company. And it's very similar ways what we are seeing in the construction industry today. So basically just tell me what you need from me, I sell you the components, I'm done. I don't care if your windshield will fix into the frame of your car, and for the wheels, I don't care if the wheels will be strong enough to support the car, because I finished my contract, that's done. And then something happened in the auto manufacturing industry that's called vertical integration. What is vertical integration? Imagine the end is customer, or you are selling the cars. The beginning is the raw material like steel, okay? The vertical integration means everything from the first step to different components like a glass, like all the electrical components, like all the structural components, all the way to the assembly of the car and to the selling of the car, the marketing department. Everything are purchased by a single company and put under the same umbrella. So that's called a group company. For some reason, that kind of transformation happened in the auto manufacturing industry. And so it's basically integrate everything inside of one single company. And what happened after that was their productivity just boosted, just flew. And that is how manufacturing, auto manufacturing industry becomes one of the most efficient industry in the world. So you probably ask, have we ever tried to do similar thing? The answer is yes. This is actually something called project delivery method. So let me think about this way. Construction integration and auto manufacturing integration are fundamentally different. Why? Because when you build a car, okay, you can all build a phone. Let's use the cell phone, for example. You can build a lot of exactly same copies before your next version, right? So you can repeat the work, but each building is different. And it's impossible for us to repeat. For most of the buildings, they are different, but for Walmart, for example, that's a different story. They use the same drawing, they use the same construction methods. But for most of the projects, we have unique buildings, we have the unique products. So we only got this temporary team, which means I bring the designer, engineers, and the contractors together to finish this single project. And once this project's done, I learned everything, I learned a lot of things from here. It can hardly be applied in the next project because the next project is new and maybe even in a new place. So the team will be dismissed and then you shake your hands, wave bye-bye and work with other teams. It's very difficult for the construction team to build a long-term relationship, the trust relationship. So it's more temporary virtual team, fragmented team. You don't share the knowledge from the previous projects. So that's the fundamental difference, okay? That means the way for construction to integrate efforts will be fundamentally different than the way the auto manufacturing is integrating their efforts. So they can buy different companies, come together. But for us, it's unlikely that a company by design, by engineering, by procurement, by all the subcontractors and become a giant company can do everything. No, because it's so unique. For example, for Kivit, it's a big company, but they have different sectors. They have different focus. They have companies focused on school projects. They have companies focused on residential. They have companies focused on offshore rigs. So it's just very difficult for them to repeat doing that. So what is the way construction doing the integration? This is called a product delivery system. Okay. Let me show you this. This is called a design, bid, build. Can anybody tell me what this figure is showing?
Owner has two separate contracts with the contractor and then a separate contractor with the designer or engineer.
Exactly. Project delivery method actually shows how we organize the contracts among different parties. The only tool we have for the construction or the AEC industry to integrate is through contracts. Unlike auto manufacturing, they can merge companies, but we can only use contracts. So design, bid, build means I basically here, the solid line shows the contractual relationship. The dashed line shows information or communication that is supposed to happen, okay? So for design, bid, build or DBB projects, the owner will sign a design contract with the designer. So that's contractual obligation. And then once design is done, the owner will sign a separate contract with the general contractor. And the general contractor will definitely have a lot of questions about the design. So they will ask the designer, right? But think about this. Is the designer obligated to answer the questions from the general contractor? Anybody?
No.
Correct. No. You could ask, but I have the right to not answer you anything. And very likely they don't answer anything from the general contractor. And then general contractors will have the contractual relationship with the subcontractors. What is the problem with this contractual arrangement? Anybody? What is the potential issue with this one?
That the contractor and the designer don't communicate.
Definitely, yes, correct. So think about that. Designers are building things virtually. Contractors are building things physically. They are supposed to be on the same page, but we are breaking their, there's no obligation for them to talk to each other. That's ridiculous. Now, the next move is what? Think about that. And what happened here is the owner, another problem here is owner doesn't have any knowledge related to design to the general contractor. So that's why we start to see a lot of problems with DVB, this kind of a contractual arrangement. So the solution the owners start to think about is to hire this consultant. This is something called Construction Management Agency or CMA. What does that mean? It means that at the early phase of signing this design contract with designer, the owner will hire somebody. Usually it's a gray-haired guy who worked in the industry for more than 30 years, who know the business. Maybe somebody has some engineering knowledge, somebody has a lot of construction knowledge, to sit next to the owner. So imagine they have a meeting here and the designer say, hey, I want to design this thing, the second floor without the first floor. And this consultant, construction manager said, no, it's impossible. According to physics, we need the first floor to build the second floor. And the owner says, wow, that's amazing. So that is actually a delivery method that will help, the owner to validate the design at the early phase. So we can somehow solve the problem that the designer is delivering a ridiculous design to the general contractor. Now, is this arrangement perfect? What's the potential problem with this one? Anybody? Anybody more than Eric? Think about it. We are brainstorming, think about that. You feel the owner, what is the potential problem with this one? You want to say something? Say something, please. All right, nobody? Okay, let me imagine this kind of thing. The owner had his consultant and everybody's happy. They deliver this thing to the general contractor and the general contractor say, oh my goodness, this is the most ridiculous design I've ever seen. From the constructability perspective, I cannot build it at all. And the owner said, no, actually, you know, I heard, you know, Tom, you know, from this ABC consulting company, and he's very experienced, you know, I think this is a great design. And then the general contractor said, no, I know Tom, he's also a ridiculous guy. He's stupid. You know, he doesn't know anything, you know, about this project. He didn't graduate from University of Florida. What he told you was totally wrong. Okay. So again, we cannot guarantee that this guy will agree with this guy's opinion, right? All right. If you're the owner, what is your next step? Come on, guys. How do we solve the disagreement between the two parties here?
How do we solve the disagreement, you said?
Yeah, like what if the general contractor still doesn't agree with the opinion with the construction manager?
Can we create a contract between the construction manager and the contractor?
Very similar. Why don't we just hire the future general contractor at early phase of the project? This is something called a construction manager at risk. If I sign two contracts at a very early phase of the project, one with the designer, one with this so-called construction manager. And so this guy will provide this pre-construction consulting service, sitting next to the owner, talking to the designer, making sure everything makes sense to him. And then later we'll sign a separate contract with the owner, which is the build construction contract. Then I cannot disagree with myself, right? What I said during the pre-construction design phase should make sense for me to build it. Make sense? So this one is called construction manager at risk. Why we call this at risk? Because you are not just providing consulting service like agency, but you are actually taking the risk for what you sign. All right, it looks better. So the owner would have more construction knowledge or constructability knowledge at the early phase of the design. Great, but there's still problem with this design. Hold on a second, let me get some water. So the problem is what, guys? The problem is between this designer and the construction manager, the communication is still dashed line, which means, yes, now there's opportunity for us to sit together to share the opinion, but still there's no contractual obligation. I'm not responsible for what I said. I'm not responsible for what I said. I'm only responsible for you, but between us, I don't have any responsibilities. Okay, so if you're the owner, what is your next move?
Making the construction manager design it and construct it.
One entity. Correct. That's what? That's design build. Have you guys heard about this? If you're here, you can give me a hands up or whatever.
Yeah.
Design build. Yes.
Yeah.
Okay, great. So yeah, that's natural, right? So now, if from the owner perspective, you know, designer, contractor, you know, you still tell me you are not responsible for what you decided to the other party. Why don't I force you guys to be the same party? You know, I want you guys to merge as one company to do both the design and construction. I just signed a single contract with you guys. Now I want to see how you fight each other. Since you guys are colleagues, you guys have lunch together, you know. So then this is called a design build project. And this new party called a design builder. And of course, they also send their, you know, subcontract with what do we call the design subcontractor, construction subcontractor, and of course, as a consultant. It looks great, right? So from the owner perspective, but then this kind of a new arrangement will create a new problem Can anybody tell me? This is actually really difficult to see, but it actually happens. It's happening. So that's why the design build is receiving a lot of criticism recently. What is the potential problem with this design? With this arrangement?
That there's no like supervision for what he does.
Exactly. Who said that?
Me, Aldo.
Okay, so great. What happened here is, imagine they are playing the game, the poker game. Now, originally you have 3 parties, everybody has their cards. And this is more kind of like a balanced structure, right? So we are striking the balance because I cannot see your cards. But think about that. What if it happens one day? You know, like the design or whatever. So I say the builder part, you know, it's kind of like inside the company, I have the design department and the building construction department. And the guy basically goes to the office of the design department and say, hey, you know what? We want to make more profit because we are from the same company. We are on the same page. Agree? Yes. Okay, you know, I understand that we do not need this pillar for this building because the soil is great. But just think about the possibility of adding some pillars. We can earn, you know, $20 million just by doing that. Would you consider the possibility of adding pillars to your design? Designers say, that sounds like a good idea. So we can get some profit, and more profit means higher salary, right? So they start to play the game against the owner. And like you said, there's no supervision on them. Then what is the final move for the owner? Everybody?
Can you repeat the question, Professor?
What is the, you know, if this is the case, you know, the owner, think about that. The owner tried so hard in the past, let's say 100 years to just change the arrangement. Finally, the owner is doing this one and we see new problems. Now, what is the final move? What is the final strategy for the owner to solve this problem?
Can the designer and the engine and the contractor be on the same contract or something like that? I don't know.
Very close. Why don't we create a single company? If I earn, you know, from the owner perspective, if I save $1, I share 50 cents with you guys. If I lost $1, you guys will be affording 50 cents for me. We are going to share the risk, but we are also going to share the profit. Let's create something called a single purpose entity, a paper company. What is a paper company? It's a company, we register company. Maybe it's a company that has 3 names. Okay, owner, designer, general contractor. But now we have this transparency policy, like you need to let me know how much you actually spend. And we will work together to reduce the cost, because I have this budget. If we reduce cost, the profit I will share with you guys. That's called integrated product delivery, or IPD. Have you heard about this term? Anybody? Hands up if you heard about IPD. Nobody? Okay. So this is actually a popular term today. And whenever you're talking about a building information modeling, you're talking about IPD. At the same time, think about that, guys. This is very similar to the vertical integration of auto manufacturing industry. Although we are not trying to build that permanent company that integrates everything, but at least we are building some temporary legal entity that integrates everything. Why IPD always come with building information modeling? That's a question, guys. Why IPD is brother sister of building information modeling? You guys are shy. Okay, so here's why. Even though we have the world most wonderful tools, you know, for sharing information, but would you think they share information? Let's say the designer has a BIM model, the general contractor has a BIM model, maybe the consultant also has a BIM model. Would they share the information? That's a simple answer, right? No. Why? Why would I? There's no contractual obligation at all. And if I'm sharing more, I will become more vulnerable. You will see the errors in my design. I don't want to do that, right? I don't want to have that transparency because the constructual arrangement doesn't ask me to do it. So even you have the most wonderful tool, but nobody wants to use it. But given this kind of arrangement, you have to share everything with everybody. Then BIM becomes so powerful. So that's why BIM plus IPD is the most promising solution to solve the fragmentation problem in the AEC industry. Make sense, guys?
Yes.
Good. Okay, so quiet.
Yes.
Yeah, so that's why we start to observe this kind of a trend, but it takes time. Like the auto manufacturing probably take about 50 years to have the vertical integration. We are actually observing that kind of a change now. You know, this one shows the 3 project delivery methods, you know, traditional design build method, and this one shows the design build method, and this one shows the construction management, including construction management agency and the construction management at risk. And we start to see the decrease of a DBB method and the increase of design build methods. But nowadays, this is kind of like old data, but nowadays we also see the increase of IPD. It's very difficult for IPD because traditionally construction is sharing very low profit. They actually have a lot of gray area to play around. They don't want to show up all their cards. They don't want to show up their actual cost. So IPD, we still have a long way to go. Just want to share you guys with something. Actually, in some companies I worked before, they have something called a zero budgeting. Anybody has heard about that? It's called zero budgeting. Nobody? Zero budget means, for example, during the bidding process, I told the owner I submitted the bid for $10 million. And when I started to build things, I found, oh, actually, I would only spend $7 million. So how about the $3 million? Should I just report them as profit? No, I will create a dummy account, create a lot of dummy cost items, and to balance, zero up my cost, I will still on paper make my cost look like $10 million. You guys got the point? So zero budgeting actually practice to cover up the profit. Because of that, IPD is extremely difficult. I think we are going through a very similar evolution as the auto manufacturing industry, but we're also having our own unique problems. All right. So any comments, any question, guys? Any discussion you want to have? Okay. So why are there multiple product delivery methods, and why, we are seeing that kind of evolution? This is more about risk allocation from the owner's perspective. Money talks. Whoever funds the project will have the force to change the industry, to change the arrangement. And if you check all the delivery methods, the DBB to the owner actually represent the highest risk, and the design build actually represent lower risk. The IPD actually represent no risk at all, it's shared risk. So this is actually the risk picture from the owner's perspective. But from other party, it's different. Let's say for general contractor, if you have the power to have the arrangement for the entire industry, which one would you go? If I were a general contractor, I would definitely go with DBB because I can hide a lot of my profit. This is actually the lump sum contract. I report a number to you. Don't ask me how much I actually spend. All things left in my pocket will become my profit. So the risk for a builder, for a general contractor, is actually the upside. DBB actually represents the lowest risk, right? And the IPD actually represents the highest risk because I probably wouldn't have that much profit. Make sense? But there are also other benefits by moving from the traditional DBB method to this new method. This one shows different phase of a project, and this one shows the efforts and the cost. This actually, you guys must remember the terms here. The PD is pre-design, ST is schematic design, DD is design development, CD is construction documentation, procurement, construction operation. So this curve shows the ability to impact the project costs and functions. So it basically decreases very fast over time. It makes sense, right? So in the design phase, everything is virtual. So it's easier for you to make a design change to impact the cost and the function. But once you start to build it, there's no way back. And this one actually shows if you want to make a change, how the cost is changing. Of course, the cost will increase. Now let's check the effort. For IPD, integrated project delivery and design build, because we are moving the builders to the early phase, their opinions to the early phase. So the effort, most efforts will spend here. Most brain energy will spend in the early phase. So we have bigger ability to impact the project. But the traditional way, the general contractor will enter the project after the bidding. So most brain energy will spend here, and there's no regret at all. Even though, hey, I don't like this design, I think we could save another $5 million by just change the design slightly. There's no way back. And this is another way to show how the different, main process, how they overlapping in terms of different delivery method. For DBB, design is design, bidding is bidding. Once bidding is done, you start to build. But for construction manager at risk, you also, it's possible to overlap them a little bit. For design build, the bidding process, design process, and the build process, they all overlap somehow. For IPD, the overlap is more. So it's not only about increasing our ability to improve the project, it's also about shrinking the entire project time. Guys, the project time is more than just the construction time. It actually involves the planning time, the design time, the bidding time, project time, construction time, and delivery time. So if there's any way for us to overlap the phases, that means the save time, and that also means the save money. And also, by moving from the traditional way to a more integrated way, we also increase the level of common understanding, right? So once again, schematic design, design development, construction documentation. This is the traditional way. The understanding will become high only in the late phase of the construction. So now we, probably when the job is halfway finished, and then we start to see, oh, now I know the intention of this design. Why didn't we do a different thing? But if I'm using this newer integrated design method, then at the early phase of the project, engineers hired, designers hired, general contractor hired, subcontractors hired. So they sit down together, they share opinion, they share their knowledge and experience. They reach this common understanding really, really early. So there wouldn't be disputes, there wouldn't be tensions, there wouldn't be reworks or inefficiencies. That's all the benefits. So that's why building information modeling plays a big role. Let me just recap a little bit. Because our industry look like this, lack of a common understanding, so many parties, nobody wants to share information because there's no contractual obligations. So our industry try something similar to the auto manufacturing industry. They just try to bring people together, bring knowledge in the early phase. They try to combine the design and the construction guys, and finally they put everybody on the same page inside the same company. And so we start to see that. And because the ultimate arrangement requires everybody to share information with everybody else, then BIM start to play a role because BIM is designed for information sharing. And so as we see more and more integrated product delivery, we will definitely see more and more use of building information modeling. That all come together, right? So that means lower risk to the owner, bigger ability for everybody to influence the project, shorter project time, better common understanding, and lower waste, okay? So that is actually giving you the sense that why BIM is becoming so popular today. And it's not just a simple technology advancement. This is also about business management method of advancement. This is about the change, the fundamental change to how the AEC industry doing business. Okay. So we are going to stop here and take a, let's say take a 20-minute break. Let's return like 43. Any question, any comments so far, guys? No? Okay, so let's return at 5:43, okay? See you then.